Hi, everybody. Mrs. Thompson here. I'm going to talk to you about how to um, graph in polar coordinates using the Desmos graphing calculator and how to recognize some basic shapes of polar graphs. So the first thing I'm going to show you how to do right now, notice that I'm in the regular graphing calculator, desmos.com/calculator. I'm going to go over here to the wrench. And I'm going to see over here that I can change my grid. This green one here is what we're in. This is Cartesian coordinates. You can switch to polar coordinates pretty easily here. So when you're in polar coordinates, this is considered your pole, the origin, and then you move radially outward. So R of 2, 4, 6 in that manner. And then your positive x-axis is considered your polar axis, and you rotate in the positive direction from that polar axis counterclockwise, like we do with the unit circle. So let's take a look at this first equation. R is equal to the cosine of theta. Notice that that gave me a circle here. You can increase the radius of the circle by changing the number out front. So that number out front is the radius of your circle. Now this is a cosine circle, which means it's going to lie on the x-axis like this. You could reflect it across by putting a negative in front like that, so that's a reflection. And then we could also have a sine circle. So a sine circle, that number out front, the coefficient will also change the diameter of your circle, whatever that number is out front there. So notice that the sine circle is oriented on what we think of as the y-axis. And you could also reflect the sine circle by putting a negative in front. So the cosine circle is oriented on what we think of as the x-axis, and the sine circle is oriented on what we think of as the y-axis. All right, so then we have what we call a limacon. All right, so a limacon has a coefficient here, which is usually referred to as A. Let me just write this in for a minute. And a coefficient in front of the cosine here that is usually called B. The shape of the limacon depends on the ratio of the A over the B. So if we have an A of, let's say, 2 and a B of 3, you can see that A over B is 2/3, which is 0.67, which is less than 1. So if your A over B is your A over your B is less than 1, then you get an inner loop. Okay, so you can write that down. If your A over your B is less than 1, then you get this inner loop here on your limacon. All right, so and as long as it's less than 1, see now my inner loop got bigger when I made the ratio smaller. All right, so A over B less than 1, you get a limacon. And you could put a negative in here, and it would reflect it. All right, so now this is a cosine limacon, and like with the circle equation, your cosine limacon is going to be oriented on what we think of as the x-axis like this. And you could get a sine limacon down here. So if we put the A over B also 2/3, the sine limacon will be oriented in what we think of as the y direction. Okay, and you could reflect the y limacon, the sine limacon, by putting a minus in the middle as well. Now, if the A is larger than the B, so A over B in this case let's say it's between 1 and 2. Okay, so between 1 and 2, so this is A over B is equal to 1.5. We get a dimpled limacon. It's got a dimple right there. Okay, so this is a cosine dimpled limacon. It's oriented on the x-axis. And then we could get a sine dimpled limacon. Let's just make it positive. And that would be oriented on the y-axis. All right, so a dimpled limacon has an A over B ratio between 1 and 2. 1.5 is between 1 and 2. All right, then one other possibility is that your A over B ratio could be greater than 2. So 3 over 1 is greater than 2, and in which case you get what we call a convex limacon. Convex limacon. All right, so when we have a convex limacon, it looks somewhat like a circle, but it's got one flattened side. So it's not really a circle, even though it kind of looks like a circle. It's a flattened circle. All right, and if you change these two numbers here, you can get it to do, you want it to be bigger than, let's see, let's just make that a 5. So you can see the flattened side a little better on that one. Okay, so this is a ratio larger, A over B larger than 2. All right, and then the final possibility for these limacons would be if A was the same number as B, right? So you put A equal to B, then you get this shape that looks sort of like a heart because of this point right here. We call that a cardioid. All right, so we can have a sine cardioid as well. And then, of course, you can do the reflecting by changing that sign in the middle there. Okay, so those are our limacons. Now let's go back up to look at these two top equations for a minute here, and we're going to form what we call roses. All right, so if I look at this top one here, let's just leave it at a 6 diameter here, but I'm going to change the coefficient of theta. So if I put a 2 in front of theta there, I'm going to create a 4-petal rose. All right, so this is a 4-petal cosine rose, and you'll see that this petal here, I always look at this first, this petal out here on the positive x-axis to tell me whether I have a cosine rose. All right, so this is a cosine rose here. I've got a coefficient of 2. All right, and I could also have a sine rose if I put a 2 here, right here, and a sine rose. Let's just make it the same diameter. Will not have its petal here, either one, any petal. It won't have a petal here on the x-axis. It'll be between the this axis here, the x-axis, and the y-axis. It'll be somewhere in between there. If you think about this kind of as the first petal here, it won't be lying right here on the x-axis. That's how I know this one's a sine rose and this one's a cosine rose. All right, so this number out front here is the diameter of your rose. It goes all the way out to this 6 line here. Okay. Now, still, if I have an even number here, let's say 4. 4 would be my next even number. Okay, what happened there is I have 4 times 2. All right, I have 4 times 2. I have 8 petals here. If I count these, I have 8 petals here. I still know this is a cosine rose because the first petal is on my x-axis. So I have an 8-petal cosine rose because 4 times 2 is 8. All right, and I can put a 4 in here, and I could make an 8-petal sine rose as well. But I know this is a sine rose because my first petal is over here and it's not over here where the cosine rose would start. All right, so if you have an even coefficient of theta, then you've got a rose such that the number of petals is 2 times the coefficient. All right, so then you could have a 3 here. Let's try that. So if I have a 3 there, notice 3 is an odd number. If you have an odd coefficient of theta, then you'll have that same number of petals. So if I have a coefficient of 3 here, then I have 1, 2, 3 petals. So I have a odd number. So this is a 3-petal cosine rose. So my coefficient of theta is 3. All right, so I could do the same thing here for the sine rose, right? And I'm going to have a 3-petal sine rose. I know it's a sine rose because my first petal that I see is not here on the x-axis. It's up in here in this first quadrant. Okay, so the petals will always be distributed evenly around the pole. So that's the case for any number of petals. So let's make it the next odd number. So I've made a 5-petal cosine rose where the coefficient of theta is the number of petals I have. See, it's a cosine rose because that first petal is on the x-axis. And I could make a 5-petal sine rose. However many petals you have, they'll be distributed evenly around the pole. All right, so it can be a lot of petals. All right, so those are your roses. And let's see, anything else? Okay, so that pretty much covers the graphs that we're going to talk about in 5.1 because we don't have a whole lot of time to spend on polar coordinates. But these are pretty interesting and usually, make a nice project if you want to be a little bit artistic with this. And there are some other shapes that we can come up with, but these are the ones that we're going to investigate. So in your homework set, you're going to see some problems where you're going to have to identify these graphs here, whether you've got a cosine or a sine rows and the number of petals. So you're going to want to base it on the information I just gave you in the video. So you'll have a few of these kind of questions where you're going to have to just discuss or match. Let's find there's one more in here that's got some limesons in it. Oops, that was it. Well, here's another one. There's a couple where you're going to have to decide which of these equations matches the limeson that you're given. Okay, so you have plenty of information in the video, which obviously you can take notes on and replay as many times as you want. All right, so let me know if you have any questions.